computer program is a list of instructions that can be followed by a computer to perform a specific task. Most programs work by taking some input data, processing that, and creating some output data. Understanding the values and types will form a foundation on top of which we can build up concepts that will allow us to write our own programs. So values are the actual underlying raw numbers and text our program manipulates. Tony Stark, the number 43, and false are all examples of values. Sometimes we'll say that when we literally write the number 4 and then the number 3 next to each other to form the number 43, that we're writing the literal 43. Same with Tony Stark. If we write the quotes, then the letters T, O, N, Y, etc. into our code, we'd say that we're using the string literal Tony Stark. Sometimes we might say that this is hard-coded, meaning that when the program runs, the literal value isn't going to change. Literal values are used a lot when you're first starting out, but eventually data will likely come from a database or some user input. Every value belongs to exactly one data type. The kinds of values that can be represented and manipulated in a programming language are known as types. All of these literals that we've written so far can be categorized as a specific type. We see string, number, and Boolean. Those are the types for Tony Stark, 43, and false. Most languages use a very similar list of super simple types, like a collection of characters as a string of text, a list of digits with or without a decimal point as a number, and then some type for representing true and false. Some programming languages will have more types that they have built in. Other programming languages will have a very small set of these primitive built-in types that you are to use to build up to more complex types. When a program needs to use a value again in the future, it assigns that value, or sort of like stores that value, in a variable. Variables have names, and they allow us to use those names in our programs to refer back to the values. We'll talk more about variables later. Here we're assigning the value 7 a name, age. We're also assigning the string Grayson to the variable name first name. If we wanted to print out the value 7 using the variable age, we might call some print function and pass in the variable name or the literal number 7. And we'll take a look at how to print out the number or the string or whatever value it is in different programming languages. There's really two different kinds of types. There are built-in types, and then there are user-defined types. Built-in types are the types that come with the language. This is the batteries included stuff like numbers and strings and dates and arrays and object types. User-defined data types are defined in terms of built-in data types and other user-defined data types. Here, we're defining a student type, or we have defined a user-defined type called a student type, which is composed of or made up of other built-in types, the number for the age and the string for the first name. We might also create a car type, which takes in a make and a model, both of which might also be user-defined types. Typically, a programming language does not let the programmer extend or redefine those built-in types. Next, a type can either be mutable or immutable. These primitive types like 7 and true are immutable, meaning they cannot change. You can change the value of the variable, meaning you can change what the name of that variable is referencing by pointing the variable at a different value. However, there's no way to change what the number 7 means. When we talk about the number 7, there's no way we can modify the number 7 to be the number 8 or the number 6. We wouldn't want to change what the number 7 means. Similarly with true, we wouldn't want to change what it means for something to be true. A mutable object can change. All right, I'm using Replit today. I fired up a brand new REPL using the C# programming language On the right-hand side, we have our terminal output. In the middle pane, we have our editor. We see that we're working in main.cs, which is the file that we're going to be working in. The boilerplate that was added here had the using statement for importing the system library. We have a class definition with a public static void main function, which will execute. And here's the code that we're actually going to write. So we're going to modify line 5 here. And this will, console.writeLine is how you can print stuff in C#. So we're going to print this string literal hello world. If we run this code by clicking the run button here, and this will execute our C# code and print to the console. And we see that it is printing out hello world. So if we remove this and type in the number 43 from our example earlier, we'll see that the number 43 is printed. Again, this is the literal value 43. This is the literal number 43. And the one other thing I want to talk about is commenting. So generally with commenting, you're going to add comments to your code to describe what the code does, to remind your future self of how something is working. And so in C# there's a couple different ways to add comments, but one way is by adding the / to some part of the line that will comment out the rest of the line. This tells C# that it should not execute the code that is commented out, or the code that comes after these two slashes. So I'm going to use a commenting out to keep track of stuff that we've already run so that you can reference it later. But this is just to show you that when you comment code out, in fact, let's comment both of these lines out and click run. You'll see that nothing is printed to the console because when code is commented out, it is not executed. All right, let's talk about printing out Tony Stark. So if we replace 43 here with Tony Stark and attempt to run our code, right? This is the string, the name Tony Stark. If we run our code, we get an error. So the error here on the right tells us that the file name that the error occurred on, so this is main.cs, and then there's two numbers here, 6 and 27. The very first number, number 6, tells us what line in this file the error is on. So we're on line 6, that error is on line 6. And then 27 tells us what character it's on. So S here is the 27th character on the 6th line in main.cs. It says unexpected symbol Stark. So this is thinking that maybe it should have a closing parentheses here or a comma, and likely that Tony and Stark are different variables or constants that are referring back to something else, but not a string literal. So when we're writing our C# code, we need to tell C# where the string, meaning like where the collection of characters begins and where it ends. And we do that with double quotes. So we add a double quote at the beginning to say where the string is starting, and a double quote at the end to say where the string is stopping or where it ends. So if we run this, we'll see that it does not fail anymore, and we get the output Tony Stark. Super cool. Let's keep going. So if we again go back here and we add 43 plus 10, now we are adding an expression. So we're not adding just a literal value 43, we're adding an expression. So we have 43 followed by the plus operator followed by the number 10. So what's happening here is this expression, everything that's highlighted, 43, the plus and the 10, that expression will be evaluated. So we're going to find what is the arithmetic result of adding 43 and 10, and then we will replace this entire expression with the value 53. So that will kind of, as the code is running, it will say, take 43 and add it to 10. Whatever the result of that is, use that and replace this expression with that value. So it would be replaced by 53. Then that 53 value is passed to the WriteLine method on the console object. And then it's going to be printed to the console. So if we run this, we get back 53. All right, what happens if we add two strings together? So let's copy that and see what happens if we try to add Tony plus Stark. Okay, so these are two string literals. Tony is one string and Stark is another string. We know they're string literals because we've written them directly into the code here. They start with double quotes, they end with double quotes, and in between these two string literals we're using again the plus operator. But it doesn't really make sense to add the string, like the word Tony, to the word Stark, right? In any like arithmetic terms, you don't add Tony and Stark and get back 153, right? So instead, what happens is when we're using strings with the plus operator, we're going to concatenate the two strings. So concatenation means linking things together in a series. So here we're going to link together the string of characters Tony and the string of characters Stark and print those out. So we'll get back Tony Stark. Something that you might notice immediately is that there's no space between the first name Tony and the last name Stark here. A couple alternatives to fixing this. One might be that we go into the word Tony, we add a space so that when it's run, we have Tony space Stark. Okay, another alternative might be to concatenate Tony and Stark with a third string in the middle that just has an empty space. So if we run that, we'll see that we get back the same thing. So Tony and Stark, right? Cool. So this is concatenation, string concatenation, super helpful for when you're building up output that you want to print to the console. Let's also print out a Boolean value, so false. False is one of our Boolean values that we talked about, and we get back false in the terminal. One thing that can be really helpful when you're working with values is to know what the type of the value is. So if we have the word Tony as a string, we can call the method getType on that string to get the type of the value. So we get back system.string. So Tony, when we're using the double quotes around Tony, the type of that is system.string. Similarly, if we replaced Tony with the number 43, we should get back the type, the data type for that number literal 43, system.int32. That's great. What if instead of using just the number 43, if 43 had some decimal value, so 43.123, if we get the type of that, we'll see that it's a system.double. If you have integer values which don't have a decimal place value, those integer values are treated a little bit differently than we would treat a floating point number that has the decimal point and some value after it. And this has to do with the way that numbers are stored in memory as binary. So it's something to keep in mind, and that these two types are different. 43 without a decimal place, 43 with a decimal place, those are two different things. All right, that's really the basics for values and types in C#.